that's the current, actually it's the current passing through R1, right? So how can you find the current? So E over R1 or V over R1. Apply Ohm's law on R1, you can find the meter and the current, the reading on the ammeters. Parallel, same potential difference. Apply Ohm's law to R1, you will find the current passing through R1. Okay. All right, this one. Okay. Before the switch is closed, what's the flow of the current from the positive side of the battery, passing through light bulb 2, and then passing through light bulb 3, right? Okay. Then after switch is closed, what happens to the current? Current from the battery now splits into the two branches, passing through R1 and R2, combined together and going back to light bulb 3 and then back to the battery. Yeah, then, okay, so after switch is closed, the brightness of light bulb 3 is brighter or darker? What do you think? Okay. Okay, before and after. So before, the switch is open, right? And then the current passes through R2 and R3, R2, R3 in serial connection, right? Okay? And then after switch is closed, so that's the parallel. Okay? And we know the equivalent resistance R12 will be that, right? So actually the value of R12 is less than both R1 and R2 according to mathematical equations. So actually the overall equivalent resistance is less, okay? Less than original R2. So the total equivalent resistance including R3 will be less. Will be less means same voltage, so current will be larger, right? So there are more larger current passing through light bulb 3, so the brightness of light bulb 3 will be brighter. Okay 吗？ Make sense to you 吗？ Okay？ 可以吗？好，哎，再讲一遍哈 ，OK？ Actually, when the switch is closed, the two light bulbs are connected in parallel, right? So the equivalent resistance will follow these equations. And we know in mass, R12 will be less than both R1 and R2, right? So switch closed, this overall equivalence will be less than R2. And combining with R3, so the total resistance will be less. Same voltage, so current will be large, right? So large current passes through light bulb 3. That means brightness of light bulb 3 will be brighter because larger current. Okay, now second. Okay. So before switch is closed, switch is closed, open. So current will follow, yeah, light bulb 1 and light bulb 2. So what happened to the light bulb 2 when the switch is closed? What do you think? Wire, so current will go through light bulb 1 here. Suppose it will split into two branches. However, this is wire, no resistance. So actually all current will pass through the, no current will go to light bulb 2. So light bulb 2 will be off after switch is closed.
对，老师在讲清楚，它是为什么？
因为你看 suppose two branches, right? However, 这边是 no resistance, 这边有 resistance.
你要怎么知道那个是 no resistance？
single. What do you think? 就是说呀，本来 current 要 go through 这两个嘛 right? However, 如果这边是一个 light bulbs, then some current will go to this light bulb. The rest of the current will go to these light bulbs, right? However, unfortunately, 这个是一个 wire.
哦，就是它那个 end 没有 light bulb，
对，
所以就直接走那边。
对，
我懂。
That's like a wire, so 就全部都走这边。So no current will pass through light bulb 2. Light bulb 2 will be off. So just like a wire. Okay. Here. Before the one more connection of the R, current 这样走 right? And that's the current passing through the battery. Yes. Now after we connect one more resistor, like this way, what happened to the total current through battery? Larger or smaller? What do you think? Parallel, right? So same voltage, right? So even before these are still the same voltage, right? Across the same battery. Okay, 如果你再加一个 there's one more branch, right? So there's I1, I2, right? Now they combine together, it goes to I. So I will increase. Right? Actually, I1 will be the same. For example, I change I get it?
Did you say
I1, I2, 好，本来没有这个的话 I equals I1, right? Okay. However, you add them together, I1 still I1. Why? Same potential difference. However, you add one more I2, right? Splitting into two branches. So coming back to the battery will be I1 plus I2. So I will increase. Okay, ma? Even before this is I1, right? Now after this, still same potential difference. Still I1. No change. Okay, ma?
所以老师他的那个，
是他的讲法。
因为 parallel, right? Parallel 的话就是 same potential difference, right? Same potential difference, same potential difference. Always the potential difference across the battery, right? So before the connection, suppose I1, right? After the connection, voltage difference across the points, still I1, right? No change. Still zero. Still 这个 V 嘛 right? So V, okay. However, you add one more branch. So joining together, you will go back to the battery. So 你又加一个 battery, 你又加一个 current. 那如果我再加一个呢 same, right? I3, and going back, I equals I1 plus I2 plus I3. 再加一个呢 I4. Okay. So same I1, same I2, same I3. You keep adding the total current. Okay,
所以 I 会
一直增加，会一直增加。这样可以啊 ，guys? Yes.
When you connect it on the I1 increase.
No, same. 因为你 same potential difference.
Is it the same current splitting?
So,
yeah, that's what
they,
So if it comes back, wouldn't it be the same current?
我们不要用
You got it.
不要用两个 resistor，我们用 just one resistor。So suppose 这样，如果这样子的话 ，OK， 那这个就是 I1 可以哈 ，OK I1 V right， 然后我如果再 connect 一个 resistor，still V 嘛 same parallel right， so here is I2 for example， so what's the total current back to the battery I1 plus I2 right， because this is parallel now splitting into two branches joining together at this junction。回来，那如果我再 connect 一个呢，就 keep connect is I3. So actually going back to the battery will be addition of the three batteries. So you connect more and more resistors, the current will be larger and larger.
Wait, larger compared to what?
Larger than
Like so larger
compared to the original I1. But as I1, alright? And 再加一个就变成 I1 plus I2 compared to the.
Okay, is the same current splitting into three? So if it comes back together, wouldn't it be equal?
No, more current splitting into three branches. 因为 even without 这两个 you already have the same potential difference. So still I1 加一个是 V 还是 same potential difference, right? 啊，如果你这个如果改成那个 plug in 的话 ，actually， 如果这个东西是个 plug in， 这个你 plug in hair dryer， 这个 heater， 然后 your sister 又加一个 hair dryer， 全部 on 的话，然后你这边的客人就会很多。Okay. So actually, on the circuit 它有一个 security check， 叫做 circuit breaker。如果 I increase, for example, 一个 threshold curve， 它就会 automatically off， 然后就会 protect the circuit。好，所以 两个 hair dryer 加一个 heater， 这个 circuit 就会自动跳开 ，because too much current passing through the power source。那这边有一个叫做 circuit breaker。After midterm, I'll show you where is the circuit breaker right here in this room. Protection about the circuit， 因为你一直用这些东西，越来越加，就是说 turn on many devices under the same circuit, you will add current through the battery. Okay, huh? Okay. So, thank you. Alright, 好，这样子哈。Current through the battery, okay, and passing through R1, passing through R2, right?
20 of these.
Let's compare the potential difference between points A and B, B and C, C and D, and D and A. Okay? Alright. So potential difference between A and B, we only care about the negative. Okay. So actually it's IR1. Okay? Okay. The potential difference across the resistor R1. Now potential difference between C and D actually is IR2. Right? The potential difference across resistor 2. And potential difference between A and D actually is the potential difference provided by the battery, E, right? But what about potential difference between B and C? Just like a wire, right? No R. That means R is 0. So potential difference between B and C will be 0. Just like a wire. Okay, huh? Okay. Up. Before the switch is closed, still open, so current will go through battery and then go through up, right? Okay. So here's the I, the current going back to the battery. 那如果这个 close 呢 ？Same, right? Okay. 那 close 的话，那你我把它画成 close 好了，就 close. So it splits into two parts, right? I1 and I2 and go back to the battery. So I will be double. Then I will be double. And what happened to the power operated through the battery? So it's I times V, right? So I is double, then V, power will be double too. 这样可以哈？ Okay. 好，然后 capacitor. Yeah. Okay. So when the switch is closed, the battery is going to charge the capacitor, right? Okay, the question is always like this. When t equals 0, right after switch is closed, what is the current passing through R1? And after a long time, after S is closed, what is the current passing through R1? Basically, it's like this. Okay. Now, at the beginning, when the capacitor got charged, right after the switch is closed, no current is on, right? But current will stay on the capacitor one by one. 刚开始的时候是没有 so no charge and no potential difference developed into the two plates. So Q will be 0, V will be 0. Okay, that means V will be 0. So that means no potential difference. But current will be free to flow onto the plate. That means it's like a wire, okay? Because no potential difference built yet, okay? So just like a wire. So when right after the capacitor got charged, remember, just like a wire. So what about the current passing through the R1? This is the wire, no potential difference. So current 会全部过来这里 okay? So when t equals 0, this is like a wire. So what's the current? V over R1. Okay? Okay? Up and then charging. The charge, kind of occupy the space of the capacitor plates and eventually saturated. Saturated means no space anymore. So charge cannot stay on it anymore. That means no charge, no flow of the charge. What does that mean? Kind of like an open gap because charge cannot be put on the plates. So when after a long time, 这个就把它看作一个 gap, okay? 按 gap 的话，so current coming from battery going through R1, here's a gap, so it will go through R2. 因为这边 broken 掉 ，OK? So what's the current through R1? V over R1 plus R2. OK? 还可以吗？好 ，so I repeat 哈，当你开始 charge capacitor 的时候 ，capacitor is like a wire, so current will go like this way. However, after a long time, after being charged, capacitor will be saturated, no more flow of the current. That means it's kind of open gap. So current 就没办法那个 cross the gap, so it will go through. Okay, okay. So T equals 0. After a long time, there's a different behavior of the capacitor. Okay. 好 okay. 3 resistor R1. Yes.
Is it possible to calculate the time when it changes?
Yeah, that means remember the differential equation, we use the exponential growth, exponential decay. We are talking about t in approach to infinity, right? That means t is infinity. So we don't use the equation, we just use the final behavior of the capacitor. Okay, at the beginning and long after. Okay.
他说那个公设背。
那个不是不用背。好。For this circuit, current comes from the positive side going through R3 and then splits into two parts, right? R1 and R2 combined together. Okay. Compare I1, I2 and I3, 哪一个最大，哪一个最小 From Kirchhoff junction loop, right? Junction rule, I3 equals to I1 plus I2, right? So I3 will be the largest. Okay. And what about I1 and I2? Same voltage, right? Parallel. So if R1 is larger, I1 will be less, right? If R2 is larger or smaller, R2 is smaller, I2 will be large. Okay? So it depends on R1 and R2. So you can compare I1 and I2. But I3 is always the largest because I3 is the addition of the two currents. Okay now? Okay. All right. So this is the non-ideal battery with an internal resistances. Okay. So the overall, the blue brass is a battery. However, inside the battery, there's a small internal resistances. Now 1 million external resistances. Okay. So the real voltage difference provided by the battery should consider the potential reduction of IR. Right? So the real potential difference out of the battery will be the D41 minus potential difference dropped by I times R of V equals IR, right? And energy dissipated by the battery internal resistance in the time interval T 要怎么算 okay. So energy is power times time, right? And we know power is IV. Now you replace V by IR Ohm's law. So it becomes I squared RT. So simply 把这个 resistor 看作一个 circuit 里面的 resistor. Okay. So you can find I, now plug in I and internal resistances, and also times the time interval, you could find the total energy dissipated by these internal resistances. Okay 哈 ，OK， 好，那还有一些东西比较简单的哈 ，for example the resistances depends on the length and also cross-sectional area. 这个 formula is listed in the formula sheet. Resistance proportional to the length, inversely proportional to cross-sectional area, and the slope we call resistivity. 如果这个 wire is double, bill is double, and resistance will be double. Okay. However, if cross-sectional area is wider, and then resistance will be reduced. 这样可以哈 Okay, and then let's go to the time constant. 等我一下哈 Okay, so when we solve 这个 differential equations, we find 有一个这个东西 So when P equals RC, what's R? R is the resistance, C is the capacitance. then we could find the charge grows by this way, 63%. Same thing for voltage build up. So we call RC is the time constant. Okay. So if we know C and R, so we could find the time constant. Okay. So one question asks you to find the time constant. Just a multiplication of R and C. 这样可以哈。OK， 然后 let's practice 那个 Kirchhoff loop rules。这个东西就是sorry， 我应该看一看这个。OK， 就是说 you need to mention the current direction first, then you decide the loop direction. Okay. Now Kirchhoff loop rules 就是说 when the loop passes through the battery or when the loop passes through the resistor, how you are going to write down the potential difference. 如果 current direction 是往这样走的话 ，you decide loop direction 是这样跑的话 ，for battery, so the loop direction from negative to positive, potential difference will increase by E. Okay. 然后呢 when the loop direction is parallel the direction of current, then potential difference will decrease by IR. Okay. 这样可以吗？然后 if you decide the loop direction 是这样跑的话。So when the loop direction passes through battery from positive to negative, 就变成 negative E. Okay? 然后呢 when the loop direction is opposite to the direction of current, then potential difference will increase by IR. Actually, 这两个是 same equation. Okay? Just decide by the direction of the loop. So when you write down the Kirchhoff equation, kind of like this, loop 1, loop 2, loop 3, they will show you which equations. So you chose which equation is the right equation, Kirchhoff loop rules for that loop. So make sure you know how to write the equations. 好，那个 junction rule 比较简单 right? At this junction, the total current should be conserved, or charge should be conserved. So input current should be equals to addition of the splitting branches current. 好，最后一个哈 ，the capacitor 有一个东西我没有忘了教，which is 这个东西。Okay. 三个 capacitor connected in parallel. What's the equivalent capacitance? Just like a resistance. Now we change resistors to capacitors. Okay. So in parallel. Okay. So 就是这个是 equivalent circuit. So we found 这个 Q 呢，就是这三个 Q 加起来 right? Q equals Q1 plus Q2 plus Q3. And we know Q can be expressed by CV because capacitor definition is Q over V. So Q equals CV. Right? So we use CV, and this is the C1, V1. And you cancel V because they are in parallel, same V. Right? So in parallel connection, equivalent resistance will be addition of the individual capacitors. Did you notice 刚刚跟 resistor 相反 right? Okay. And again, 3 resistors are connected in serial. And what's the equivalent resistance? Okay. So V1 plus V2 plus V3 will be equals to total V. Then replace V by Q over C. Okay. Same Q. 这边 charge Q, 这边 charge Q, 这边 on the same wire should be same Q. Now by Q delete, you will find the expressions. Now, 刚好跟 resistor 相反。So I make a conclusion right here. 对不起啊。Remember mechanics 还有一个 spring, right? Spring connected in series. What's the equivalent spring constant? Okay. So resistor in series is the addition of all individual resistances. In parallel, it follows that equations. Capacitor 刚好相反 right? Now spring constant mechanics belongs to the category of capacitor. So my way to remember this is 我只记那个 resistor OK， 然后 split 跟 convention 刚好就是相反。OK， so will questions asking you to find the equivalent reducers. The equation is exactly the opposite equation of the 20 billion reducers. You can remember this way. 然后 spring constant 跟 convention 刚好是相反，这样就可以了。Alright, thank you for your all attention.